Plan quality. The plan quality process determines what quality standards are applicable to the project, and how the quality requirements will be met. This process is performed by the project management team using several key outputs from other project management processes. Quality planning is usually done in parallel with other project planning processes because the underlying approach is that quality is planned, designed, and built into the project and not something that is added on later. This process is performed by the project management team, and it's done in parallel with other project planning processes because the underlying approach is that quality is planned, designed, and built into the project and not something that is added on later. The plan quality process results in quality metrics, quality checklists, the project quality baseline, the process improvement plan, the project quality management plan. Quality metrics are the specific quality goals the project must meet and how the quality control processes will confirm compliance. Quality metrics can include any type of applicable measurement, including defect rates, bug rates, failure rates, uptime, reliability, and coverage area. Quality checklists are documents that outline the key steps that must be performed as part of quality control. Checklists are to-do lists that ensure that everything is performed and in the correct order. The quality checklists that will be used later during the quality control process are developed here. The project quality baseline is the agreed-upon level of quality requirements the project must meet. It's the quality objectives of the project and the subsequent plan for achieving those objectives. In other words, the quality baseline is the current project quality management plan, which itself reflects all approved changes affecting quality. Plan quality. Inputs. Scope baseline. The scope baseline is the approved project scope statement, WBS, and WBS dictionary. The baseline incorporates all approved changes. It's very important for quality planning because it describes the acceptance criteria, and includes other details that may directly impact quality and grade levels, such as technical specifications of materials. Stakeholder Register. The Stakeholder Register identifies all project stakeholders and contains attributes such as the person's name, title, position, project interest, expectations, and influence. Meeting customer and stakeholder expectations is necessary for quality. Schedule baseline. The schedule baseline is the approved project schedule. It has the start and finish dates for all project activities, which impact quality requirements. Risk Register. The Risk Register is a comprehensive list of all threats and opportunities the project faces. It also contains supplementary data about each risk, including its impact, probability, risk response, budget, risk owner, and contingency and fallback plans. Risks likely impact the project quality requirements. Enterprise environmental factors. Factors outside the project boundaries that affect quality planning can include regulations and industry standards and guidelines. Organizational process assets. The project quality policy is directly related to the organization quality policy, and may include the quality methods of other organizations, such as the customer. Policies, procedures, and templates may also be available for the project team. Lessons learned and historical information from past projects is also considered during quality planning. Plan quality. Tools and techniques. Cost-benefit analysis. Cost-benefit analysis. Cost-benefit analysis helps determine the appropriate trade-off between quality and the cost to achieve that level of quality. Cost of quality. The cost of quality quantifies the cost of adhering to the expected level of quality in the deliverables. It is a time and financial determination based on the needed level of quality the deliverable must meet. Control charts. Control charts are types of run charts that are used to determine whether processes are in control or out of control by comparing measurements taken over time. Benchmarking. Benchmarking compares processes between different organizations, helping to generate ideas for improvement and to provide a measurement basis by helping the organization determine what the standard is. Design of experiments. Design of experiments is a statistical method that can help make processes and products more efficient by mathematically simulating changes all at once to the variables affecting the process. Statistical sampling. Statistical sampling is a general term that applies to a number of different and industry-specific techniques that look at a subset of a population in order to determine a measurement sampling. Flowcharting. Flowcharts are graphical representations of a process, showing sequential activities, branches, and decision points within the process. Proprietary quality management methodologies. These include specific methodologies like Six Sigma, Lean, Quality Function Deployment, and CMMI among many others. Additional quality planning tools. Additional tools, such as brainstorming, affinity diagrams, force field analysis, matrix diagrams, and nominal group techniques, help to define the project quality requirements and plan for the project quality management activities. Plan quality. Outputs. Quality management plan. The quality management plan is a component of the project management plan. The quality management plan details the quality policy of the project, including how the project management team will address quality assurance, quality control, and continuous improvement for the project. Quality metrics. Quality metrics are the specific quality goals the project must meet and how the quality control processes will confirm compliance. Quality metrics can include any type of applicable measurement, including defect rates, bug rates, failure rates, uptime, reliability, and coverage area. Quality checklists. Quality checklists are documents that outline the key steps that must be performed as part of quality control. Checklists are to-do lists that ensure that everything is performed and in the correct order. Process Improvement Plan. The Process Improvement Plan is a subsidiary plan of the Project Management Plan. It describes how processes will be analyzed to find and remove non-value-added activities. Project Document Updates. Documents that are likely to be updated during the plan quality process include the Stakeholder Register and the Responsibility Assignment Matrix for quality activities. Process Improvement Plan. The Process Improvement Plan is integral to quality management's focus on continual improvement, and it details the steps that will be taken to analyze the project processes and eliminate waste and improve the efficiency of processes. This is accomplished by streamlining processes and eliminating non-value-added activities, which will occur during the perform quality assurance process. The Process Improvement Plan will include process characteristics and boundaries, a description of the process, what the policies are behind the process, what its purpose is, when it's to be performed, and why it's needed. The roles involved in the process, including the process owner and process stakeholders. The starting and ending points of the process. The information or data it requires. The process inputs and outputs. The activities involved in the process, its relationships or dependencies to other processes. Process configuration. A visual rendering, such as a flowchart, process map, or activity diagram, of the process illustrating all major systems, components, relationships, and process interfaces. Process metrics. The measurements that will be performed against the process. Compiling measurements against a process can often be tedious and difficult, so whenever possible it's best to incorporate some automatic means of measurement collection within the process. Process improvement goals. The specific goals for process improvements, including what the targets will be and how will they be measured. Quality management plan. The quality management plan is part of the project management plan, and the quality activities in it are executed during the perform quality assurance process. The quality management plan establishes the project's quality policy and describes how the project team will implement that policy through continual improvement activities, quality assurance activities, and quality control activities. The performing organization's quality policy is the foundation upon which the project's quality management plan is built. The project scope statement provides the deliverable requirements, and since quality is about fulfilling the customer requirements, the scope statement and stakeholder register are the source for those needs and expectations. Organizations with a mature quality management approach will likely have a quality department that can provide assistance to the project management team. But there are two common challenges the project management team may face when beginning quality planning. The first is that the performing organization may not have quality policy, and the second situation is when there are several organizations involved in project activities and each has its own quality policy. In either of these situations, it's up to the project management team to draft an agreeable quality policy for the project. This means that the project management team needs to have a good knowledge of overall quality management and its application to the type of project being undertaken. When no organizational quality policy exists, developing a project quality policy can take some time, but the extra effort can also benefit subsequent projects by providing a growing library of templates that they can draw from. Once drafted, the quality management plan undergoes some approval process. The acceptance of the quality management plan establishes the quality baseline for the project. This baseline is what level of quality the project and its product, service, or result will meet. The project size, scope, complexity, and application area are some factors that determine how extensive and formal the approval needs to be. On some projects this may involve only the project management team, while on others the customer, stakeholder, and company management might be involved. Quality planning tools. Quality planning tools help to determine both the content of an activities that will be taken while implementing the process improvement and project quality management plans. These tools also have many uses beyond quality and can be used for product analysis, process analysis, alternatives identification, and risk analysis. Quality planning tools are: cost of quality, cost-benefit analysis, benchmarking, brainstorming, statistical sampling, control charts, design of experiments, flowcharting, affinity diagrams, force field analysis, nominal group technique. Matrices. Cost of quality. Quality involves costs, and the cost of quality quantifies this cost. The cost of quality has two main components: the cost of conforming to quality requirements and the cost of not conforming to quality requirements. Cost of good quality, cost of conformance. Prevention costs. Quality management activities, such as training and process documentation and checklist development. Appraisal costs. quality assurance activities, like appraisals and audits, quality control activities, like testing and inspections, cost of poor quality, cost of non-conformance, internal failure costs, failures found by the project team, including the costs related to rejects, rework, delays, shortages, scrap, and other inefficiencies, external failure costs, failures found by the customer, including costs related to warranties, returns, lost sales, and lost good. Many conformance costs are easy to measure since they can be tracked and quantified, but much of the costs of non-conformance can be difficult to determine, such as lost sales or a tarnished reputation due to poor quality. Cost-benefit analysis. As it relates to quality, cost-benefit analysis helps to determine the appropriate trade-off between quality and the cost to achieve that level of quality. The goal of meeting the quality requirements is to reduce costs through less rework and higher productivity, but there are costs associated with meeting the quality requirements, and what we want to find is the agreeable level between quality requirements and the costs associated with meeting those requirements. And just as we avoided gold-plating the scope, we likewise want to avoid gold-plating the quality requirements. Exceeding the customer's quality requirements results in quality costs incurred by the project that provide no real benefit to the customer. Another purpose of cost-benefit analysis is related to continual improvement. As we strive for improving products and processes, we do not want to exceed a point beyond which the costs of the improvements are not offset by the anticipated increase in revenue, sales or profits. This type of analysis is called marginal analysis. Benchmarking. Benchmarking compares similar processes between different organizations, helping to generate ideas for improvement and to provide a measurement basis by helping the organization determine what the standard is. Benchmarking can also help process re-engineering by introducing new approaches to existing processes. Technique. Identify the process, problem or issue to be addressed. Benchmarking does not have to be formal to be effective. It can be as simple as sharing practices with others through a PMI chapter meeting. Find other companies that have a similar process, including researching public information on what companies have a reputation for best in breed. Approach personnel from those companies, share the current process and ask them how they handle it. If applicable, survey trade group members such as through news groups, user groups, or online community forums. Incorporate the new ideas learned and brainstorm to develop a new strategy for the process, problem, or issue. Implement the new process or practices, and follow up by measuring the results and adjusting the process as needed. Brainstorming. Brainstorming is a general term applied to a large number of different techniques in which group members spontaneously share ideas, often to find alternative approaches and solutions to problems. To get a better pool of ideas to choose from, brainstorming sessions should include a diverse group because a mix of participants with different backgrounds, experiences, and skills. Technique. A facilitator poses an objective to the group. The facilitator wants to encourage participants to think broadly about the problem and not focus too narrowly on ideas or solutions, and during the first part of the session, there shouldn't be any evaluation or criticism of any ideas mentioned. The facilitator should record all suggestions. After sufficient time has elapsed, the group turns towards categorizing, combining, and refining the list, and then analyzing the revised list of ideas. Eventually the suggestions will be narrowed down further and prioritized, ending up with an action plan. Statistical sampling. Statistical sampling is a general term that applies to many different statistical techniques that look at a subset of a population in order to determine a measurement sampling. Depending upon the industry or project area, significant knowledge about probability and statistical techniques may be required by the project team. Control charts. A control chart is a type of run chart that is used to determine whether a process is in control or out of control. A run chart is a line graph that displays measurements taken over time, and with the addition of upper and lower control limits, the chart shows at what points in time measurements exceeded thresholds, which aids in finding the root causes of anomalies. Design of experiments. Traditional experimentation usually involves changing one factor at a time and then analyzing the result. But that is time-consuming in a DOES and take into account the interplay that may be going on between multiple factors. Design of experiments is a statistical method that can help make processes and products more efficient by mathematically simulating changes all at once to the variables affecting the process. The results can then be viewed to see how the changed factors not only influence the end result but how the factors relate to each other. Flowcharting. A flowchart is a graphical representation of a process. There are a lot of different flowcharting approaches, but they all show the sequencing of activities, relationships, branches, and decision points in a process. Flowcharts help everyone to better understand the process by seeing it broken up into small, step-by-step components. Affinity diagrams. An affinity diagram helps people address complex issues through brainstorming and data categorization. Affinity diagrams can be used to generate ideas, identify issues, and find relationships between factors contributing to an issue. Once categories are established, the affinity diagram can be used to prioritize items and develop an action plan. Technique. Identify the topic, problem, or issue. Choose a group facilitator. Brainstorm to generate ideas, potential solutions, or contributing factors. Sort the items into similar categories without too much initial thought. As themes begin to emerge, create header categories that establish the unifying relationships between items in the columns. Continue finding ideas and categorizing them until ideas are exhausted and the columns are grouped into categories agreed upon by the group. Construct the final affinity diagram. Force field analysis. Developed by social psychologist Kurt Lewin, force field analysis aids in visualizing the pro and con forces involved in an issue or situation. The premise behind this technique is that a situation is held in equilibrium by two sets of opposing forces. Driving forces are those striving for change, and restraining forces are those desiring the status quo. A situation can change only when the strength of the driving forces exceeds the restraining forces. By concentrating on the core factors giving strength to the restraining forces, the desired change can proceed. Nominal group technique. Nominal group technique (NGT) is a brainstorming derivative developed by Van de Ven and Delbecq that involves not only group brainstorming but individualized brainstorming. It's useful for new groups where the members are not yet familiar with each other, the issue is controversial, or there are group members who are more vocal than others. NGT starts out with each individual privately generating ideas which are then discussed with the group. Technique. Choose a group facilitator. Make sure the topic or issue is clearly understood. Allow several minutes for the group members to privately write down as many ideas as possible. Taking turns, each individual states his or her ideas to the group. At this point there is no discussion from the group on the idea. The idea presented can be from the person's list or a new one he or she just thought of. As ideas are presented, The facilitator writes the ideas down on a common list that's visible to all. Keep this up until all ideas are exhausted. Each idea is then discussed by the group. Wording may be changed or ideas stricken from the list if all of the group members agree. The facilitator needs to keep the discussion relevant, healthy, and objective during this step. From the modified list, the ideas are prioritized by some form of secret balloting. The items with the highest votes can then be used for further prioritization or as action items. Matrices. Matrices are rows and columns of data, typically thought of as spreadsheets. Matrices are versatile tools that help analysis, decision-making, and prioritization. A matrix diagram shows relationships between factors, causes, and objectives, and the prioritization matrix provides a way of scoring or ranking action.